Hello students, welcome to my class. Today we are going to discuss few questions related to amines and the pattern is JEE advanced pattern. So friend, let's start with the topic, that is the question answer round. Look, read the question carefully. This is my first question. What is given here? That is the compound which on reaction with aqueous nitrous acid. What is given here? Aqueous nitrous acid at low temperature produces an oily nitrosoamine. Do you remember this? How to differentiate 1 degree, 2 degree and 3 degree amine? If it is 1 degree amine, then what will happen? It will give you alcohol. But if it is a 2 degree amine, then what will happen? One treatment with aqueous nitrous acid at low temperature, it gives a yellow oil. Remember this? It gives a yellow oil. So in this case, what will be the answer? Methylamine 1 degree amine, ethylamine 1 degree amine, triethylamine that is the 3 degree amine, and diethylamine that is the 2 degree amine. Clear to you? So in this case, if I take 2 degree amine, then treatment with HNO2. Clear? Then treatment with HNO2, it can be written like this, HONO. Then what will happen? It gives you R2N. Clear to you? Double bond, that is NO. Clear what I am telling? R2N double bond NO, and this is, we people know, that is the yellow oil. What I am telling? This one is a yellow oil, and we can say this is nitroso, yes sir, amine. This one is nitrosoamine, that is R2NH plus HNO2. It gives you a yellow oil, and this is known as nitrosoamine. Clear? If you have any doubt, you can easily approach to me. That is resonating structure R2NNO, or simply it can be written like this, R2N into NO. Clear to you? This is the yellow oil. So for this we say the amines is diethylamine, that is, this is the product CH3 CH2, yes sir, halt twice. Clear to you? That is NH plus OHNO, that is HONO. Then what will happen? It gives you, that is CH3 CH2, that is halt twice NNO, or it may be written like this, N into NO. This is the yellow oil. So we people can say for this D is the correct option. Now friend, I am going to rub this part and we'll discuss the next question. Wait for a moment. Now let's move to the next section. Next question is, check it out, the correct increasing order of basic strain. Look at here, here is CN, here is the involvement of double bond, and here is NH2. As we know, amino group, amine, has more a basic character in comparison to the cyanide and double bonded component. So the correct order, increasing order, will be CH3 CH2 CN. Okay. Then there comes CH3, then N, then double bond CH3, yes sir, then there comes CH3, CH2, NH2. This is the correct order. CH3, CH2, CN, CH3 and double bond CH, CH3 and CH3, CH2, NH2. So for this question, we people can say which one is the correct option? That is C is the correct option. Clear? That is NH2 group. This comes from NH3. It can be written like that. We people know H, NH2, H plus, NH2 minus, and if I remove H and add this group, that is the alkyl. So it will have more basic character in comparison to the rest of the two. Clear? So for this question, C is the correct option. Now I am going to rub this part and we'll discuss the next question. Now let's move to the next question. This is the question number 3. The boiling points of amines and their corresponding alcohol and acid may vary in the order. As we know, higher the ease of the formation of hydrogen bonding, higher is the boiling point. Clear? Yes, clear. If I talk about amines, that is, it contains NH2 group. Yes sir. Wait for a moment. If I talk about alcohol, it contains OH group. Yes sir. If I talk about carboxylic acid, then it contains COOH group. Clear to you? That is amines, NH2, this one is alcohol, OH, and this one is CW. Now, in all the three cases, which one have more tendency to form hydrogen bonding? As we know, in case of carboxylic acid, there is more tendency of the formation of hydrogen bonding, that is more tendency of association. If the tendency of association, if the tendency of hydrogen bond formation, if the tendency of hydrogen bond formation increases, then we people can say that is the boiling point also increases, because there is an increasement of association. We people know generally acetic acid in forms of dimer. Why dimer? There is a more tendency to the formation of hydrogen bonding. So association is much in this case of carboxylic acid. If more association, then it will have more boiling point. Then there comes oxygen, comes OH, that is alcohol. After carboxylic acid, the hydrogen bond formation is better in case of alcohol, that is OH group. Then there comes amine. Here is also the tendency of hydrogen bond take place, but the ease of formation of hydrogen bond is less than alcohol and carboxylic acid. So which will have more boiling point? Carboxylic acid. And which will have less boiling point? That is amine. One more thing I am going to include here. If I talk about 1 degree, 2 degree or 3 degree amine, then what will happen? So it's very simple. In 1 degree amine, there is 2 hydrogen. In 2 degree, there is only 1 hydrogen. And in 3 degree, no hydrogen. So if we move from 1 degree to 3 degree, the boiling point decreases. 1 degree will have more boiling point than 2 degree than 3 degree. Clear? So now in this case, what will happen? COOH group will have more boiling point than OH group, then NH2 group. This is the correct order. So now check it out, which one? That is R, D option, R CH2 NH2. Then there comes ROH, RCH2OH. then there comes ROOH. Here is RCH2H, one OH group. Clear to you? So in this case, we people can say D is the correct option. Clear? What it decide, that is ease of, if the ease of formation of hydrogen bond is more, then boiling point is more. Clear? Now I am going to rub this part and we'll discuss the next one. Wait for a moment, friend. Now let's move to the next question. What is the next question? Look at, now tell me what will happen. That is, by passing the mixture of vapor of alcohol and excess of ammonia. By passing the mixture of vapor of alcohol and excess of ammonia over heated alumina, the main product, this is a simple one, do you remember this? By passing the mixture of vapor of alcohol, if I take alcohol CH3 CH2OH and then treatment with NH3, excess of ammonia, that is the ammonolysis, then what will happen in presence of Al2O3 at 350 degrees Celsius. Now what will happen, how the reaction process, as I told you earlier, if you do not know the mechanism, then put plus and minus sign, generally you will get the output easily. So that is, put here minus sign, put here plus sign. Yes sir. Now in case of NH3 you can write like this, H, that is NH2, H plus NH2 minus. Now wait for a moment, it will move here. So the product is CH3 CH2 NH2. Yes, CH3 CH2 NH2, and the next one is H2O. So we can say in this case the amine is primary amine. The amine is primary amine. Clear? So for question number 4, what we observe? For question number 4, we observe the main product in this case is nothing but a primary amine. So for question number 4, A is the correct option. Clear? Now I am going to rub this part and we'll discuss the next one. Now let's move to the next one, question number 5. Among the following, the weakest base. Now which will decide the weakest basic nature? Generally, first of all, inductive effect. Clear to you? That is inductive effect. Yes sir. In this case, plus I effect. More the plus I effect, more is the basic character. That is, more the minus I effect, less is the more the minus I effect. That is, more is the acidic character, less is the basic character. Then the second one is, we people know steric hindrance, steric effect. Yes sir. And the third one is generally, that is the resonance. These are the factor. Now in the given question, look at what we have to observe. This one is C6H5CH2NH2. This one is also aliphatic amine. This one is not aniline, friend. This one is like this, CH2NH2. Clear? Second one is C6H5CH2NH, that is 2 degree, and the third one is NO2 CH2NH2. Look at one thing. As we know, NO2 group is electron withdrawing group. That is, here minus I effect dominates. if minus I effect dominates, then it will increase, tell me, the acidic character and will decrease the basic character. So in this case, in all the cases, they all are electron donating group, but in case of donation is more powerful. Here is slight cases, that is, but in case of this, there is the dominant minus I effect. So if there is a dominant minus I effect, then definitely it will have less basic character in comparison to the all. Am I right? What I am telling, it will have a less basic character in comparison to the all. So it is very simple here. The basic character in this case, which will decide the basic character, that is here the inductive, and no need to use the resonance, because here we do not need to arrange them arrange them in order of basic character, increasing basic or decreasing basic character. So here the question is, among the following, which one is the weakest base? This one is the weakest base, because there is an involvement of more involvement of minus I effect, and which will ultimately decreases the basic character. So for question number 5, we people can say that is C is the correct option. Clear, friend? Now I am going to rub this part and we will discuss the next question. Wait for a moment. The next question is question number 6. Now look at, read the question carefully. Do you remember this? Wait for a moment. What is given here? Check it out. Read the question carefully. I am giving you a few seconds. Read what is given here. That is, it given ethyl chloride on hitting with AgCN forms a compound X. Listen, here is ethyl chloride C2H5Cl. On treatment with AgCN, remember this, on treatment with KCN, on treatment with NaCN. If there is KCN and NaCN, there is a formation of cyanide take place, alkyl cyanide. Remember this. But if there is AgCN, there is a formation of isocyanide take place, that is NC, and here is CN. Now the question arises here, when ethyl chloride is treated with AgCN, it forms X. X is alkyl isocyanide or isonitrile, and the isomer of X is CN, that is cyanide. What I am telling, then according to the question, when ethyl chloride is treated with AgCN, it forms a compound X. Write the name of the compound which is the isomer of X. The compound X is isocyanide and the functional isomer of isocyanide is cyanide. Clear to you? So which one is the correct option? That is, don't get confused, this is the product X, not according to the question, the functional isomers of X. Look at, read the question carefully, otherwise you will get wrong answer. X is C2H5NC, but the functional isomer of X, so functional isomer of X is C2H5, isocyanide. Cyanide is the functional isomer of isocyanide. Here the product is C2H5NC, and the functional isomer of C2H5NC is C2H5CN. This is the final answer. Clear? If you have any doubt, you can easily approach to me. The question looks tough, but it's not tough. Sometimes question look easy, but it's not so easy. Read the question carefully, otherwise you will get the wrong answer. So for question number 6, C is the correct option. I'm going to rub this part and we'll discuss the next one. Wait for a moment. Now, let's move to the question number 7. An aliphatic amine on treatment with alcoholic carbon disulfide, okay, and mercury chloride, okay, forms ethyl isothiocyanate. This is a simple question. An aliphatic amine, that is RNH2, clear to you, on treatment with alcoholic carbon disulfide, that is CH2, and mercury chloride, that is HgCl2, clear, it forms ethyl isothiocyanate. What is it? Form ethyl RNCS, ethyl isothiocyanate, plus HGS and plus HCl, and we all know this will smell like, this will look like as a oil, mustard oil, smell like a mustard oil, ethyl isothiocyanate. So we people can say, remember this reaction during my lecture I have discussed this. The reaction is Hofmann mustard oil reaction. This is one of the famous reaction. What the reaction is? Hofmann's mustard oil reaction. So for question number 7, C is the correct option. RNCS. This is the correct option. Clear? It can be written like this: bond C double bond S. That is mustard oil like smell. So the answer is Hofmann mustard oil reaction. Clear, friend? I think you can easily solve such kind of questions. Now I am going to rub this part and let's move to the next segment. Wait for a moment, friend. Now, question number 8. A mixture of 3 amines. A mixture of 3 amines can be prepared. Remember this, that is ammonolysis of alkyl halides and ammonolysis of alcohol. These are the two methods by which we get a mixture of 3 amines: primary, secondary, as well as tertiary. So for question number 8 is a very simple question. C and D are the correct option. Clear to you? Now friend, I am going to rub this part and we'll discuss the next segment of question. Check it out. That is the question number 9. Now tell me what will happen. HNO2, that is definitely, if it is giving alcohol, then definitely this one is primary amine. So it gives definitely C4H9. That is the involvement. If I take the isomeric form, there are various isomeric form. Around 4 types of primary amines we give. Here is given, that is 3-degree alcohol. Then definitely X can give carbylamine reaction, Hofmann mustard oil reaction, and diazonium salt as the intermediate. Clear to you? How many primary amines are possible? Remember this: C4H11N. That is, it can be written like this: C4H9NH2. Now tell me how to write the isomeric form. So it's very simple: CH3, CH2, CH2, then CH2, then NH2, first one. The second one is, sir, CS3, CH, NH2, CH2, then CH3. This one is the second one. What is the third one? Sir, it's very simple. The third one is CS3, CH, CS3, then CH2, then NH2. 1, 2, 3, and 4. This one is the third one, and the fourth one is CS3, CS3, then CS3, then NH2. This is also a fourth form, and in this case we can easily observe if it gives alcohol, then the product in this case we can say carbyl amine reaction, primary amine, that Hofmann bromide, because in HNO2 if there is 2-degree amine, that is the green oil. If there is 3-degree amine, there is a formation of salt take place. I have discussed all these things, how to differentiate 1 degree, 2 degree and 3 degree. So if there is a primary amine, it can give you carbyl amine reaction. So if this pattern combined with HNO2, then there is a formation of 3-degree alcohol. So we can easily observe that the amine is primary amine, so it can give carbyl amine reaction. It can easily give Hofmann mustard oil reaction and diazonium. Hofmann bromide reaction for amide, conversion of amide, treatment of amide with Br2 and NaOH or alkali, it gives you amine. Conversion of amide into amine is known as Hofmann bromide reaction. So for amines, 1, 2, 3. This is a multiple choice type question. For this question, A, B, C are the correct option. Clear? Now I am going to rub this part and we'll discuss the next question. Wait for a moment. Now my next question is, check it out. Read the question carefully. This is a passage type question. Amines are basic compounds. Clear? They act as Lewis bases, okay, due to the presence of lone pair of electron. Definitely due to the presence of lone pair of electrons, they act as bases, okay. Amines also behave as Arrhenius base as well as Bronsted base, okay. Now next one is, amines also behave as Arrhenius base as Bronsted bases. That is, the reaction here is given. Arrhenius bases and Bronsted base. Bases are those which accept H plus ion, or bases are those according to the Bronsted, that is which accept protons. Look at the reaction, you can easily find it out. They act as a Bronsted bases. Basic character of amine depends on the factor like inductive effect, like steric hindrance and resonance. Alkyl group and electron releasing group, hence these groups, alkyl groups and electron releasing groups, hence these groups increases the electron density at nitrogen as well as the basic character. That is, as we know, plus I effect, if the number of alkyl group increases, that is the electron donating group increases, basic character increases. Basic character of tertiary amine is reduced due to the steric hindrance. In case of aqueous solution, as I told you, the basic character decreases in case of 3-degree amine, but in gaseous phase, that is the order is 3-degree. That is 3-degree amines, because there is 3 CS3, or you can say there is 3 alkyl group and more plus I effect. But in aqueous solution, 2-degree amine will have more basic character than 3-degree and 1-degree. That we have no. Now, which one of the following is most basic? As I told you, if the medium is gaseous, normal phase, that is 3-degree, that is the dominant plus I effect. But if I talk about aqueous medium, then 3 resonance, we have to watch the resonance also, we have to check out the steric hindrance, we have to check out the plus I effect also. And after comparing the all, what we get, in case of basic solution, 2-degree amine, in case of aqueous medium, 2-degree amine has more basic character than 3-degree and 1-degree. Now let's move to the next one. Which of the following factor influence the basicity of amines? We people know 3 factor: inductive effect, polar effect and the resonance. That is, here one also is missing, steric hindrance. Polar effect also play a role, that is the polarity comes. when dissolved in aqueous medium. So the basicity of amine depends here the inductive effect, the polar effect and the resonance. For this question we people can say that is D, A, 1, 2 and 3 all options are correct. Now I think friend you are very much familiar with such kind of questions, you can easily solve such kind of question if you have a strong. So revise the things again friend, wait for a moment. So tell me what will happen for question number 1, that is the 2 degree amine, that is diethyl amine. Okay. For question number 2, C is the correct option. For question number 3, what will happen? D is the correct option. Clear to you? And for question number 4, what will happen? We get primary amines. A is the correct option. For question number 5, what is the correct option? C is the correct option, minus I effect here. So for question number 6, what is the correct option? Functional isomer A. No, this is one C, because the product X is A, but the isomer, that is C, alkyl cyanide, alkyl nitrile. Now here as we know an aliphatic amine treatment alcoholic carbon, that is Hofmann mustard oil reaction. Now a mixture of 3 amines can be prepared by ammonolysis of alkyl halide and ammonolysis of alcohol. C and D are the correct. So multiple choice type question. Now for question number 9, what will happen? This reaction is carbyl amine, primary amine, carbyl amine, hydrogen Hofmann mustard oil and diazonium salt. A, B, C and the correct option, and this method is for conversion of amide into amine, and here this one is amine, not amide. For question number 10, as I told you, that is here D is the correct option. For question number 1, D is the correct option. For 2, that is the C is the correct option, CS3 halt twice 2 degree amine. C is the correct option. Check this thing. D here and C here. Clear? And now for question number 3, D is the correct option. I think now friend you can easily solve such kind of question. So time is calling, time to say bye bye. Thank you so much.